In the previous section, we have introduced some development toolsets and shown how to use them. In this section, we will focus mainly on the HTML5 and CSS3 web technologies. This video is going to talk about HTML with regard to two areas: Introduction to HTML5 and how to optimize DOM resources. Before we start, we need to discuss and solve a problem: screen size. Mobile devices always have different screen sizes, screen resolutions, and pixel densities. This means our web page may look different on different screens. For example, if we develop a web page for a 3.5-inch iPhone screen with a resolution of 320 by 480, the web page will be 1/4 of the size on a 3.5 iPhone with Retina screen. If we open the Hello World web page in a Retina device's browser, it will appear quite small. The same problem occurs on Android and tablets. To solve the issue, we need to add a viewport meta tag in the HTML page. Now it looks correct, and the user's scalability is disabled as well. To use HTML5 features, we need to enable HTML5. Add a doc type at the beginning of our HTML document, and this informs the browser that we are going to use HTML5 features. Canvas is one of the most powerful HTML5 features. It can be used to generate fast and dynamic graphics using JavaScript. Most mobile devices support it. For example, I will create a signature component using Canvas. First, add some basic HTML code and the meta tag that was introduced before. Then we create a canvas element with a specific ID, width, and height. We also add a border to make it more prominent. After that, we create a JavaScript file and write the signature component there. Create a signature module so that all the JavaScript code is running inside the closure. Think about the signature process first. When the user touches the canvas, the signature starts, and the canvas draws lines when the user moves his or her fingers on the screen. The signature process ends when the user's finger leaves the canvas. Therefore, we need a variable to flag whether signatures have started or not, two variables to keep the coordinates of the last position of the user's finger, and a canvas element and the context inside it. Now we need to get the canvas and the context object when the document is loaded. We can use jQuery's document ready command if we're using jQuery. Use the document's getElementById method to get the canvas element. Then, get the 2D context object from Canvas. After that, we need to write some functions to handle the signature process. We first write a startSignature function. This function mainly changes the isBegin variable and gets the initial coordinates. We need to get the coordinates from the event object, and we write a helper function to do so. Since there is no offset x or offset y in touch events, we need to calculate them ourselves. Use the event's client position, which is the relative position to its target's container, minus the canvas's offset position, which is the relative position of the canvas to its container. Now we write the startSignature function. The endSignature function acts in the opposite manner. It sets the isBegin variable to false and cleans the last coordinates. Then we write the drawSignature function. It first checks whether the signature has started, and then draws a line between the last coordinates and the current coordinates. The beginPath method starts a path that will be used to draw the line. The moveTo function moves the cursor to the mentioned coordinates. Then the line2 function adds a line to the path. Finally, the stoke function draws the path. We then use the current coordinates as the last coordinates. Now we need to attach those functions to Canvas elements. Then we link the JavaScript file to index.html and try it in Google Chrome. It seems to be working well. Let's try it on a mobile browser. In most situations, mobile browsers perform in a similar manner to what we see in the app. Here we have an issue. The window moves up and down. We can solve that by preventing browser default actions. Try it again. It works. Video and audio tags in HTML5 are used to create video and audio streaming. It's very simple to use. You can either use JavaScript to control it, or use the built-in control panel. For example, I've created a video tag streaming an MP4 video using the built-in control panel. Let's see how it works in Google Chrome. Different mobile devices will handle it differently. For example, iPhone devices will use the built-in QuickTime player to open the video in full screen mode. While on iPads, it will play as an embedded video, and the user can manually open it in full screen. Geolocation allows the user to share their geographical position. It is widely supported by almost all mobile browsers. It is as simple to use as coding a one-liner JavaScript code. Using geolocation with Google Maps can tell the users where they are on the map. We can find the latitude and longitude of our position too. It is the same on mobile devices. The local storage allows the app to store lightweight data for offline use. The size of the data is usually less than 3 megabytes. Here we write a simple example to save and load data. The example will load and display the stored name and allow the user to set a new name and store it. The getItem method will get the value of the key. Null will be returned if the key does not exist. The setItem method takes two parameters, that is, the key and the value of the key. We reload the page after it is set. OK, let's see how it works on the browser. It should behave in the same manner on mobile browsers. HTML5 supports advanced forms. This feature is more prominent on mobile devices. Mobile devices render the input in a native manner. However, it's not fully supported and will fall back to using the original text input if the device does not support it. Since the PhoneGap mobile application is working on a single page, it's very important to arrange your page elements in an efficient manner. Although the DOM can handle infinite elements, devices have limited computing resources. We need to remove unused elements from the DOM and add them back dynamically. We can also easily load images in an image list and display images that can only be seen by the user. In this video, we have introduced how to use HTML5 in a mobile application. In the next video, we'll talk about CSS. In the previous video, we talked about HTML and HTML5. In this video, we will talk about CSS and CSS3. The CSS introduced in the first half of this section has been proven to work on most devices. However, we need to be careful when using the CSS discussed in the second half of this section. For most CSS3, we can use a neat tool called CSS3 Generator, which can be downloaded from this URL. Here, I have mainly demonstrated how it looks and what we need to take care of before using it. The border radius property sets the radius of the four corners of a DOM element. It uses few resources. The box shadow property adds a shadow under a DOM element. It uses few to medium resources, depending on the size of the shadow and the blur radius. text shadow property is similar, but adds a shadow under the text. It likewise uses few resources. We can create an iOS-like embedded text effect easily with this. The RGBA allows an extra alpha channel to set the opacity of the color. It uses few resources. The gradient function creates a gradient of color. It actually creates an image. It uses a lot of resources. Avoid using it with a long list. The transformation applies a transformation to an element. It uses medium to high resources depending on the complexity of the transformation. Here is a list of CSS that we should use carefully. The fixed position property fixes an element at a certain position on the screen. However, it doesn't behave as we expect it to on most devices. Avoid using it as much as you can. The overflow scrolling property is widely required in mobile applications. However, it does not work as expected on some devices. Even on iOS 5 and 6, which provides scrolling that has a native feel, it doesn't render the scrolled elements properly. We can use an alternative solution, such as iScroll. The transition property adds animation to DOM elements when CSS changes. It performs well in most situations. However, it is slow even on the latest iPad when the number of elements in the animation is large. In this video, we've introduced some HTML5 and CSS3 features. In the next video, we will talk about JavaScript and some libraries.